All right, welcome back, mathematicians. Today we are starting our unit on angle relationships. So the first part of this unit deals with what we call parallel lines cut by a transversal. Oh my goodness, what does that even mean? Well, let's find out. Before I move on, if you haven't done so already, make sure you have clicked on the virtual notebook and you have made a copy. Okay, I've created boxes where you can fill in the notes as I go along with this presentation. So again, if you haven't done that, go ahead and stop this video and make sure you have made a copy of your virtual notebook for this unit on angle relationships. All right, so let's get going here. So here I've got parallel lines cut by a transversal. So we know when we have two parallel lines, that means those lines will never touch. So if you look at this diagram right here, I can see that these two blue lines are what we call parallel. If I extend these lines forever, they will never touch each other. That means they are parallel. And so if I look at this red line, I've got a red line that is going through or intersecting both of my parallel lines. Okay, so we call that red line our transversal. So I have two parallel lines cut or intersected by a transversal. So that's what that means when we say parallel lines cut by a transversal. So if you look, I've got 8 numbers here, right? That's because if I take a transversal and I cut two parallel lines with it, I will create 8 angles, right? Here's an angle, 2, 3, 4, 5, 6, 7, 8. All right. So when we're talking about parallel lines cut by a transversal, we have what we call the exterior or the outside of my parallel lines. And then we have the interior or the inside of my parallel lines. Okay. So here again, here are my parallel lines, these two blue lines. They are cut by a transversal, which is represented by this red line, which creates 8 angles. And within all of this, we have the exterior or the outside of our parallel lines and the interior or the inside of our parallel lines. So now let's talk about our angle pairs or different types of pairs of angles we create when we have parallel lines cut by a transversal. All right, so if you look, I'm looking at the top right here. So it says when parallel lines are cut by a transversal, 8 different angles are formed. That's what we just discussed. So here are my two parallel lines. Here's my transversal that is intersecting or cutting through those two parallel lines. And so then we've got some blanks we're going to fill in. Again, if you click on the blank on your notes, you will be able to type in what is on this presentation. So it says an angle labeled A is blank to any other angle labeled A. Well, if I look, I've got 4 angle A's here, right? 1, 2, 3, 4. So any angle A is going to be congruent. Okay, we've seen that word before. We know anytime we see congruent, that means it is the same or it is equal. So any angle labeled A is congruent or equal to any other angle labeled A. So this A is the same as this one. This is the same as this one. This is congruent or the same as this one. All right. Same thing with any angle labeled B. So here are my 4 angles labeled B. 1, 2, 3, 4. So any angle labeled B is also congruent or equal to any other angle labeled B. All right. So the third blank says any angle labeled A is blank to any angle labeled B. So any angle A is blank to any angle labeled B. Those are what we call supplementary. So if you remember, supplementary angles are when I have 2 angles whose measures add up to 180 degrees. So if I take any angle A and I add it to any angle B, I will get 180, okay? And it doesn't matter which one, as long as it's an A and a B, if I add those 2 angles up, I will always get 180. That's what we mean when we say supplementary angles. All right, so now let's dive in and talk about the different types of pairs of angles that we create. So the first type, I'm looking up here on the left-hand side. So if I look, here's my parallel lines, here's my transversal, I have an A right here, and I have an A right here. We call that corresponding angles. What that means is I have two angles that are in the same relative position. So here's my transversal. If I look at this top A, it's above my parallel line and to the left of the transversal. Same thing with this A. This A is above this parallel line and also to the left of the transversal. That's what we mean when we say same relative position. They're in the same position, right? Top left, top left. All right. So those are what we call congruent angles. So any corresponding angles are going to be congruent or equal. And so here's another example of corresponding angles, right? Bottom right, corresponding, same position. All right, the next type of pair. So here's my parallel lines. Here's my transversal. I have an A up here, and then I have an A down here. We call those alternate exterior angles. So alternate exterior angles are on opposite sides of the transversal and outside the parallel lines. So alternate means they're on opposite sides of the transversal. So if I look, here's my transversal. This A is on the left. This A is on the right. They're on opposite sides. That's what we mean when we say alternate. And we say exterior because they are on the outside of my parallel lines. Remember, exterior is outside, interior is inside. Both of these are on the outside, so they are exterior. They're on opposite sides of the transversal. So we call those alternate exterior angles. And any alternate exterior angles are also going to be congruent or equal. And here is another example of two alternate exterior angles. All right, next pair. Here's my parallel lines. Here's my transversal. If I look, I have an A that's below this parallel line and to the right of the transversal. Here I have an A that's above this parallel line and to the left of the transversal. We call those alternate interior angles. So just like we have alternate exterior angles, we also have alternate interior angles. So they are on opposite sides of the transversal, right? This one's on the right, this one's on the left. So they are alternate. They're on opposite sides, but this time they're inside the parallel lines, right? Any area inside or between my parallel lines is what we call the interior. So these are alternate interior angles. And again, anytime I have alternate interior angles, we know that they are congruent or equal. And here is another example of alternate interior angles. All right, and then we have our parallel lines here. Here's our transversal. So here I've got an A here, and I've got an A, looks like it's just diagonal to this A, right? So you guys have actually seen this type of pair before. We call these vertical angles. So vertical angles means they are opposite angles formed by intersecting lines, okay? So here's a line that intersects it, right? Those are two intersecting lines. So if they are on opposite sides of those intersecting lines, we call those vertical angles. So they are directly diagonal or opposite of those intersecting lines. And again, vertical angles are congruent or the same. All right, and so here would be another example of vertical angles. So vertical angles are close. They're just opposite of those intersecting lines. All right. So I'm looking at this box up here on the top left. So let's talk about our transversal. All right. So the transversal is any line that intersects two or more lines. Now, what's important to note here is that the transversal is not always going to be diagonal. So if I look at this first example, here I have two parallel lines, right? I know they're parallel because they never touch. If I extend these lines forever, they will never touch. They are parallel. And then I have this line that intersects those. So the line that cuts through my parallel lines, that's my transversal. So in this case, it is the diagonal line. However, let's look at this example to the right. So here I can see that these are my parallel lines, right? So this time my parallel lines are the diagonal lines. I know they're parallel because they don't touch, right? But now my transversal, or the line that intersects or cuts through my two parallel lines, is now this horizontal line. So remember, your transversal can either be diagonal or it might be horizontal or vertical. Okay, but you need to remember that it's just the line that cuts through those two parallel lines. So you always want to identify your parallel lines first and then your transversal, because your transversal is the line that goes through or cuts through those two parallel lines. All right, so I'm looking right below that. So we've talked about this briefly before. So these are supplementary angles. So again, supplementary angles are any two angles whose measures add up to 180 degrees. Okay, supplementary means they add up. So if I take the sum of any two angles and I get 180, we call those supplementary angles. So when I have two parallel lines cut by a transversal, any angle A and any angle B are going to be supplementary, any of them. So if I take this A and I add it to this B, I will get 180. It's supplementary. If I take this A and add it to this B, I will get 180. If I take this A and add it to this B, again, 180. Or if I take this A, add it to this B, I will also get 180, supplementary. All right, so now let's talk about same side interior angles. So same side interior angles. What we mean are two angles that lie between parallel lines on the same side of the transversal. So if I look, here's my parallel lines. They don't touch, they're parallel. Here's my transversal, or the line that is intersecting those two parallel lines. So any angles that lie between, right? So any angles that are inside of my parallel lines, that's our interior, and they're on the same side of the transversal. So if I look here, this A is inside my parallel lines. It's to the left of my transversal. This B also inside my parallel lines and to the left of the transversal. So same side interior angles. All right, again, on the other side, same side interior angles. This A below or inside my parallel lines to the right of the transversal. This B inside my parallel lines to the right of the transversal. Same side interior angles. So if I have same side interior angles, that means I also have same side exterior angles, or any two angles that lie outside the parallel lines on the transversal. So remember, inside, interior, outside, exterior. So same side exterior. So if I look, this A is outside my parallel lines to the left of the transversal. This B outside the parallel lines to the left of the transversal. We call those same side exterior angles. Same thing on the right side of my transversal. So here I've marked it in black. This A is outside my parallel lines to the right of the transversal. This B outside the parallel lines to the right of the transversal. They are also same side exterior angles.